Number 45, I was asked to find the center and radius. No, 45. Given the center and radius, find equations with sphere centers and radius are given. Okay, so one way to word this is the sphere with center 1, 2, 3 and radius square root of 14 is the set of order triples x, y, and z in R3 such that x minus 1 squared plus y minus 2 squared plus z minus 3 squared is equal to square root of 14 squared. That is, you could simply say the set with center 1, 2, 3 and radius square root of 14 is the solution set to the equation x minus 1 squared plus y minus 2 squared plus z minus 3 squared is equal to square root of 14 squared. Going on to 52, I'm partway through that. And my video making program has been trying to catch up with me all day. The solution set to this algebraic equation, well, it'd be nice to put that in standard form. I see that it is quadratic in x, y, and z, and also that the x squared, y squared, and z squared terms all have positive coefficients, 3, 3, and, well, 3. Okay, that's the signal that the solution set to this is going to be a circle, but I'm going to put this guy in standard form first. So what I'm going to do is for x and y and for z, for all three variables, I'm going to perform this procedure called completing the squares. So what that means is, first of all, I'm going to collect together all of the x terms. And looking through here, I made the mistake. I thought that there was an x term over here, but I remembered incorrectly. When I went back to look for it, I saw it wasn't there. So let me tell you what I was thinking. 3, now I'm going to collect all the y terms. There was a y squared term, and hey, here's another y squared, or not y squared term, but a y term. There was a 2y, but I want to factor out that 3. So I need to do this. Okay, all right, so now I've taken care of all the y terms. 3 times 2/3 y is simply that 2y right there. I have done this because now I have 1 times y squared plus something times y. That's going to be useful in the process of completing the square. Doing something similarly for the y variable, I'll have, let's see, I'm sorry, for z, I'll have 3 z squared, and then I want to put the other term there, minus 2. I need a 3 to make up for that 3 times z, and is equal to 9. Okay, so all I've done is some algebraic rearrangement of the left-hand side of this equation to obtain this equivalent equation, and I got a little bit more work to do before I'm in standard form for equation of a circle. This term is fine, 3x squared, it's already a square, and 3, what I'm going to do this time is I am going to divide the coefficient of y by 2 to get 1/3, and I'm going to add that squared and subtract it, 1/3 squared. All that within this big parentheses that goes with that. Okay, I did that because now this expression right here is a perfect square. Similarly, 3z squared minus 2/3 z, I'm going to take 1/2 the coefficient of z to the first power, that's 1/3, add the square of it, and subtract the same thing. Okay, and the big parentheses and say equal to 9, and hope that I can read my own writing later, because I unfortunately started running out of paper there. Boy, look at all this blank space I left over here. Bad planning. Next, I told you that some of these terms, like this one, can be nicely factored, and we're going to do that. 3x squared, let me not bunch things up to the right so much this time. Okay, I've got a 3 and y squared plus 2/3 y plus 1/3 squared. That is y plus 1/3. Yeah, where do I put it? Put a parenthesis there and there, squared. All right, that takes care of all this stuff, but I still need to subtract 1/3 squared. 1/3 squared, and man, I better promote this to one of those right angle-y brackets so that I can remember exactly where it is. Okay, so I've taken care of all this y stuff, and now I have a perfect square in y. That's a y plus 1/3 squared. Notice that there's no y squared part anymore. Rather, there's y plus something squared, and that gets me closer to standard form. Similarly, over here, I've got 3 z. Now it's going to be z minus 1/3 this time, squared, and minus 1/3 squared, and the angled bracket is equal to 9. And lastly, I'm going to just simplify things. This is going to be, you know what, I better divide every term by 3. Check that out. 3 there, 3 there, 3 there, 3 there. If I divide every term by 3, I'll get an x squared plus y plus 1/3 squared. Gosh, I should have divided by 3 way earlier. At any rate, minus 1/3 times 3, so minus 1/3 right there. I just put that on the other side. That would be 3. Now once I divide 9 by 3, I'll have 3. And I add to that 1/3. Right, that's this 1/3 times 3 over there. And I also have z minus 1/3 squared. And then I've got this guy I need to take care of, and minus 1/3 times 3. Oh, wait a minute. I'm doing too many things at once, so I'm getting confused. I divided by 3, that made this a 3, and then I did not have to multiply through by that 3, so that should have been a 1/3 squared. Okay, good. And then similar for this guy, a 1/3 squared. Okay, this doesn't look very good, but is the circle with center, and I can read off the center from the standard form here. Let's see, 0 for x, negative 1/3 for y, and 1/3 for z, and radius, it's got to be the square root of that. The square root of 3 plus 2 times 1/9. Plus 2/9. There. I'm done.